Hello everyone, today we're talking about parabolas, section 9.1 in our book. Okay, these parabolas are going to be a little bit different than what we're used to seeing with quadratics. Okay, they're going to have this generic form if they're vertical with x squared equal to 4py. So it looks something like our general quadratics. We're just going to have a coefficient in front of our y. That's going to give us our focus and our directrix of the parabola. So you'll see as I go through the examples exactly what these terms mean. But as far as we're concerned, our vertex is always going to be at 0, 0, the origin. Our focus is going to be at the point 0p, and p you'll see we'll solve for in our examples, and you'll see how we go ahead and graph the focus. And the directrix is going to be y equals negative p, whatever p happens to be. So if you can see here, we have a focus here. Our directrix is just the line y equals negative p. And this is for a vertical axis, which means our x is squared. Okay, so then likewise we have horizontal parabolas when my y is squared. And then everything else is pretty similar, except here it's going to be x equals negative p, and my focus is at the point p, 0. But our vertex will stay at 0, 0. And if it's a positive graph, it's going to go to the right, because my x values are positive, so they go to the right. And if for some reason we have a negative value in front of our x, then we're going to go to the left. And we always want to make sure we get our equation into this generic form, then we can see our critical points for our graphs. So first example here, they want us to find the focus, directrix, and focal diameter of the parabola, then sketch it. Okay, so we can see here, let's get it in generic form, or standard form. So we get x equals 7y squared. And if you look at general form, there's never a coefficient in front of my squared term. So I'm going to have to divide by 7 and see that x, I'm going to write it as 1/7, so x times 1/7 equals y squared, because if you look at our generic form, and this is obviously a horizontal, right, because our y is squared, we always have a coefficient, which is 4p being multiplied by our x. That's why I wrote it as x times 1/7. Okay, so now that we know that x times 1/7 equals y squared, this is my standard form. So we know that 4p equals 1/7, right? Because x times 4p equals y squared. And so 4p, this is the focal distance. And I'll show you when we get to the graph exactly what the focal distance means. But for right now, just know that our coefficient being multiplied by our x is the focal distance. And then I need to find p all by itself, so I can find where the focus is and where the directrix is. So if I want to go ahead and find p, I'm just going to divide both sides by 4. So I find that p is 1/28. So now that I know that p is 1/28, I've got my focal distance. This means we're going to have a vertex at 0, 0. All right, our vertex is always going to be 0, 0. Our focus is going to be, okay, our focus, if you look back, our focus is always p, 0. That's why I had to solve just for p. So I know that my focus point is 1/28, 0, right? It's horizontal, so the 1/28 goes in my x. And my directrix is x equals negative 1/28. So the vertical line, right? So it's going to be, and since our graph is positive, it's just going to be a vertical line with a negative, x equals negative p, in this case negative 1/28. So you see when I draw the graph exactly what I mean by those. And just realize that the directrix is always just negative p. So whatever our focus, right, p0, directrix is just negative p. And focal distance is 4p, but you got to remember focal distance can't be negative. So if this happened to be negative 1/7, for example, our focal distance would still be a positive 1/7. Okay, so now we should know everything we need in order to draw our graph. I'm going to do a very rough sketch because we're dealing with 1/28 of numbers, so it doesn't fit on a typical graph so easily. But actually, we can just call it what we want. So we see that our focus is at the point 128, 0. Okay, our vertex is always at 0, 0. Our directrix is going to be at the point, right? Each one of these lines represents 1/28. So our directrix is the point x equals negative 1/28. So it's just that vertical line. And then in order to draw our parabola, we need to know the focal distance. The focal distance being how wide is our parabola at the focus, right? So I have to know where my parabola is going to hit. That depends on how wide it is at the focus. Well, we knew that the focal diameter was 1/7. So the focal diameter is the total distance from the top to the bottom. Okay, but this is the total. So if I want to find how much I have to go up and how much I have to go down, I'm going to divide that by 2. So I'm going to say 1/14 is how far up I have to go, and 1/14 how far down I have to go. So if we see that each one of these lines is 1/28, well, 1/14 is twice, right, is 2 times 1/28, so we'll get these points here, and so this will be the point 1/28, 1/14, or 2/28, right? And this will be the point negative 1, or I'm sorry, still a positive 1/28. That's unfortunate. So a positive 1/28, but we have a negative 1/14 for my coordinate. And this will get easier as we graph a couple. So if I go ahead and draw my parabola, looks something like that. Keep in mind that this focal distance here, that's what we mean by focal distance, is 1/7. Because if you take 1/14 and add 1/14, it's going to simplify down to 1/7. So I know fractions scare us, but it's really not that bad. When you break it down and do a couple examples, you'll see real easy to find the graph from the equation. So next, they want us to use a graphing device to graph the parabola. So in order to use the graphing device here, we're going to have to solve for y. So if I solve for y, I get x equals 2y squared. And then obviously divide by 2. So I get x times 1/2 equals y squared, right? If we keep it in the same kind of form. And then I take the square root. So I'm going to rewrite it just to make it a little bit easier to plug into the calculator. So remember, I get y equals plus or minus. Whenever I take the square root of a number, I have to do plus or minus square root of x/2. If I just multiply the x and the 1/2. So real quick, I'll do that on the graphing calculator for you. So we have y equal to positive square root x divided by 2 and negative square root x divided by 2. And when we graph it, you'll see that we get a horizontal parabola. So something we're not used to seeing, right? Normally we're used to seeing parabolas either opening up or opening down. Now we're going to have parabolas opening right and opening left. In this case, since once I got it in standard form, everything had a positive value, it's going to open to the right, and we can see here with a parabola opening to the right. Okay, next, find the equation of the parabola whose graph is given. Okay, so they're telling us that this square here has an area of has an area of 16, but if it's a square, right, both sides have to be equal, so what distance times what distance would give me 16? Well, that must mean my directrix is the line x equals -4. And remember, your directrix is negative p, so that must mean that my focus over here is the point 4, 0. Okay, so now I know a lot to work backwards and go ahead and get my equation. Right, general form here, since it's a horizontal equation, we're going to get y squared equals 4px. Okay, so y squared, I found out that p must be equal to 4, right? Because my directrix was at -4, directrix is always negative p, so that means p is at a positive 4. So my equation is y squared equals 16x. And that's it. From the picture, I'm able to get my standard form. So all we really have to do is be able to find p, and then we can plug it in and find our general form. Finally, find the equation of the parabola whose graph is given here. Okay, so here we can see the focus, right? That's our focus there at the point 0, -2. So this one should be pretty easy to solve as well. So since this one is a vertical, right, our generic form is 4py equals x squared. Doesn't matter which order you write them in. So y 4p equals x, whatever. Either form is going to work, right? Multiplication, we can do it in any order. And here, since our focus is at -2, our p is -2. Okay, so that means we get a -8y is equal to x squared. And that's our standard form. And if you graph this in your calculator, you'll see you get this vertical parabola facing down back. So go ahead and try the example problems that accompany this in the PowerPoint. Give them your best effort. Answers are down below. Okay, so we should all be on the same page when we talk about it in class tomorrow.